Another way of solving systems equations is using the substitution method. Let's do a quick review on what is substitution. So let's say you had the expression 2x plus 3y minus 4. And they want you to evaluate this expression, and they tell you that x equals negative 3 and y equals 5. So you just take this negative 3 and this 5 and you plug them in everywhere you see their respective variable. So you'd have 2 times negative 3 plus 3 times 5 minus 4. And then you would evaluate that from there. So we get negative 6 plus 15 minus 4. Negative 6 plus 15 is 9 minus 4 is 5. Okay? Alrighty, so we get 5. So that's just a quick refresher on what exactly is substitution. You're just taking something that a variable equals or that something else equals, and you're plugging it in everywhere you see that variable. So we're going to take that and we're going to apply it to systems of equations. So again, systems of equations, two linear equations, you're just trying to figure out at what point do the two lines cross. So let's say we had the equation y equals 3x plus 29 and negative 1/2 x plus 2y equals 25. Okay? So in this case, in the substitution, you're going to be looking, do I know what a variable equals? And the variable may not equal just a straight up number. It may equal some expression. What I mean by that is if you look at y is by itself, all by its lonesome on one side of the equal sign. And it's equal to some expression. It's equal to this expression 3x plus 29. So we know what y equals in terms of another variable. So we're going to take this 3x plus 29. We're going to plug it in everywhere we see a y in the other equation. So let's go ahead and do that. So we'd have negative 1/2 x plus 2 times. Now, I'm always going to put, whenever you substitute in for a variable, not just a systems equation, just anytime you're substituting in for a variable, put it in parentheses. No matter what, put it in parentheses. So we have 2 times the expression 3x plus 29 equals 25. And now we're going to solve this. So we have negative 1/2 x, and now we're going to distribute this 2, positive 2. So we're going to distribute the 2 through the parentheses. So plus 6x plus, now 2 times 29, 58, equals 25. Negative 1/2 x plus 6x, well that's 6 minus 1/2, that's 5.5. So we'll just write 5.5. X plus 58 equals 25. We have 5.5x equals 25 minus 58. So we have 5.5x equals 33, negative 33. And divide both sides by 5.5. And I'm going to go to my calculator, negative 33 divided by 5.5. And I get negative 6. X equals negative 6. All right, so now we know what x equals. So now we can use that information and plug it into either equation here. It really doesn't matter which one. I prefer to go with the equation that's already solved for a variable. So I prefer to go with like the y equals. But that's my preference. You could easily plug it into the other equation too. Just solve for y, you're going to get the same answer. Let's go with the top equation. So I have y equals 3. Now instead of x, I'm going to plug in what is x. Again, I'm substituting. This is all about substitution. So I'm substituting in negative 6 for x and adding 29. And I get y equals negative 18 plus 29. And I get y equals 11. So the solution to this system of equations is negative 6, comma, 11, x, comma, y. And I could check it. So I could plug in 11 equals 3 times negative 6 plus 29, and I could have negative 1/2 times negative 6 plus 2 times 11 equals 25. And I would solve both of these and make sure that it does indeed make both equations true. And it does. We get 11 equals 11, and we would get 25 equals 25. And so it checks out. And so our answer is negative 6 comma 11. All right, in the next video, we're going to work through a couple more examples just for the extra practice.